Okay, so let's continue from where we left off. So we're talking about the different types of matrices, and so the next type is triangular matrix. And as the name suggests, triangular matrix means it's for a special class of matrices. Obviously, it's for square matrices. Anything above or below the diagonal of the triangle, only those elements are non-zero. And so again, in this there are two classes, upper triangular or lower triangular matrix. And so for the general case, A equals Aij, M by N is upper triangular if Aij equals 0 for all I greater than j. And as a practical example, this is an example of an upper triangular matrix. Conversely, A equals Aij, M by N is a lower triangular if Aij equals 0 for all I less than j. As an example, okay, then there's one more definition called the trace of a matrix. And the trace of a matrix is defined as the sum of all the diagonal elements of the matrix, and this again works for only for square matrices. So trace of A is defined as the sum of all the diagonal elements, I equals j, Aij. So for example, if you have a matrix like so the trace of this matrix, simply the addition of 4 plus 5 plus 6, that is 15. Okay, so now that we have taken a look at some of the special types of matrices, we want to do something with matrices. So not just simply write them as a representation of numbers, we want to be able to play around with them and do something with them. And so for that purpose, we need to do comparisons, or compare between not just one matrix but two matrices or more than two matrices. And for comparable matrices, so here's a definition. For matrices to be comparable, they need to satisfy a certain condition. So let's say A is one matrix, Aij M cross N, and this is a general class of matrices, not necessarily square. Then you have a second matrix, Bij P cross Q. Then you can directly compare between A and B only if M equals P and N equals Q. So in other words, the number of rows of A should equal the number of rows of B, and the number of columns of A should equal the number of columns of B. So what can you compare? Well, you can compare, is A equal to B? So for example, if A is let's say 1 0 4 minus 5 and B equals 1 4 0 minus 5, then you will notice that this is a 2 by 2 matrix, this is also a 2 by 2 matrix, and element by element you can compare that A equals B, because Aij equals Bij for all combinations of I and j. Now here is where the order in which you write the elements becomes important. Now if you have a third matrix, C equals 1, 0, 4, minus 5, then doing an element by element comparison, you will see that although these two, the diagonal elements are the same, the non-diagonal elements are flipped now, so they're different. And so comparing that, A not equals C and C, B also not equals C, even though A equals B. Then the next kind of operation that you want to do is, can you add or subtract matrices, just like you add or subtract numbers. So you can do 2 plus 3 equals 5. Can you do that same kind of operation on a matrix? Well, yes, the answer is yes, you can, again, if the matrices are comparable. So let's take a different color. And so we're trying to see when can we do addition and subtraction on matrices. Now these operations are valid only if A and B are comparable. So which means, again, let's take the generalized form. A equals Aij, M cross N, B equals Bij, P cross Q. Then you can define addition, subtraction on these matrices if M equals P and N equals Q. Then you can define C equals Cij, a new matrix which has dimension x cross y as A or plus or minus B. So let's take an example. So if A is 7, 8, 9, for example, and B is minus 2, minus 2, minus 2, then if we try C equals A plus B, you simply add the elements on an element by element basis. So 7 minus 2 would be 5, 8 minus 2 would be 6, and 9 minus 2 would be 7. And if you want to do D equals A minus B, then that would be 7 minus minus 2, so that is 9 and 10 and 11. So before we jump on to the next section, some properties to know about matrix addition or subtraction. So the first property is it is commutative, which means that provided these operations are defined and they exist, that is, you can compare two matrices A and B, the order in which you do the operation does not matter. So A plus B or you do B plus A, they're both going to give you the same result. Addition subtraction is associative, which means that if you have three matrices A, B and C which are all comparable, then you can do A plus B plus C, or you could do A plus B plus C, and you would again get the same answer. The third property is what is called as the existence of an additive identity. So for, let's put this down, existence of identity. So for every matrix A, there exists a null matrix or a zero matrix, which if you add to A, the result stays the same. And the last property that we should remember is an existence of an inverse. So for every matrix A given by Aij m cross n, there exists A inverse or negative of A, where each element is multiplied by -1, such that A plus minus A gives you the 0 matrix. So these are 4 important properties of matrix addition and subtraction that you need to know.